And we are live. Okay, so little Missy is not going to be teaching you, so I'm going to put her down. She just wants to say hello. And you're going down there, lie down, stay. This is a West Bromwich Albion shirt. I like it because I like the colors. It is cold outside Sunday night. Well, that was a couple of nights ago anyway. Cold Sunday night was awful. It was so cold. When I do my woodworking, I go outside and do it up there because of the sawdust. And my hands, I couldn't even feel my fingers on Sunday. But it's gotten a lot better and it's supposed to be not too bad for the next few days. So let's do some math. Yes, so we're still with percent. We are on the third lesson of percent. And some of it's going to seem like a fractions lesson. I mean, look at this. This is fractions. But what I'm doing is I'm reviewing some of the things that we use in fractions that then become really helpful when we're studying percent. So let's just do a quick review of expanding and reducing fractions. But my focus here is in the way that's useful for percent, because having a fraction with 100 as the denominator is so useful when you are working with percents. So how do I get 100 to be the denominator? Well, this fraction 3/4 has 4 as a denominator. This is not a very difficult one because it's easy to figure out what do I do to a 4 to turn it into 100. I multiply it by 25. So I multiply it by a clever form of 1, which in this case is going to be 25 over 25. That's the same as multiplying by 1, so I'm not really changing the number. Then when I do that, 4 times 25 is 100, which is what I wanted, and 3 times 25 is 75. I have a fraction over 100, which of course is so easy to convert into a percentage. It's therefore 75%. So yeah, easy one. Here's another one. Not really much harder, but how do I get 20 to turn into 100? I multiply it by 5. So I multiply this fraction by the clever form of 1, which is 5 over 5. 20 times 5 equals 100. That's what I wanted. And 7 times 5 is 35. I have 35 over 100. Therefore, I have 35%. Easy and fun. Don't forget to write the percent symbol. Okay. But what about when we have the fraction that has a denominator that's bigger than 100? When we do that, we need to divide. Of course, this is a multiple of 100, 200, so it's pretty easy to see what we're going to do. If I divide 200 by 2, I get 100. So I'm going to do that. I'm dividing it by a clever form of 1, which is 2 over 2. I'm making sure this fits in the video, but I think it's fitting fine. 200 divided by 2 is 100, which is what I wanted. 180 divided by 2 is 90. So I have 90%. Very useful. Now, all of these examples involve whole numbers. When I did my dividing, I didn't end up with decimals. But we'll move on to some like that later, and we'll see that it doesn't really make it any more difficult. Not for those of us who know how to work with decimals, which we do. Okay, how about this one? We have a denominator of 700. I'm going to divide this by 7 over 7. 700 divided by 7 is 100. That's what I wanted. And 49 divided by 7 is equal to 7. We have 7/100, which of course is equal to 7%. Okay, so yes, those were a bunch of easy ones. I'm going to erase and then I'm going to do some multiple step ones. Multiple steps? Why? Sometimes there's a reason why. So let's talk about one of those reasons right now. Erase these. And my first multiple step example is, what if I have the fraction? I think I'm going to do less examples at a time so I can write bigger and stay in the middle. What if I have the fraction 42/60ths? Okay. No, that's not the one. I accidentally wrote down the next example. We'll see 42/60ths again really soon. No, what if I have 2/5? Okay, so one reason that we could do it in multiple steps is if we want to expand our fraction in stages. Now, I think the students realize that I can multiply 5 by 20 and I get 100, but I'm just pointing out that if I wished, I could say, it's really easy to turn a 10 into 100. I'm going to turn this 5 into a 10. I'm going to multiply by 2 over 2. And that gives me 10 as my denominator and 4 as my numerator, but now I still don't have 100. So I can multiply this by 10 over 10. So that's one reason that we can go in stages if we really want to. And it's not wrong. It took a little longer. I write a little bit more, but it is correct because I'm expanding a fraction, I'm following the rules of fractions, and then I'm expanding the fraction that I got as an answer. This is all fine. Another reason, what I'm really getting at, for doing it in multiple steps, and we're back to that 42/60ths that I wrote before and erased, so let me write it again. This is a little bit different. Let's see where I am on the rectangle. 42/60ths. Now, 60 doesn't multiply easily to get 100. It is possible to multiply 60 by a number that will give you 100, but that can become a little complicated. So one of the things I like to do is to say, well, you know what? I can multiply 60 by a number easily and get 600. So that's what I'm going to do. I'm multiplying this by 10 over 10. And 60 times 10 is 600. And 42 times 10 is 420. Now, why did I do that? Because getting 60 to turn into 100 was a little bit of an ordeal. But getting 600 to turn into 100 is easy because it's a multiple of hundreds. So what I did was I multiplied this by a clever form of 1 that would result in a denominator that I think will be convenient, and then I can do that with the second step. So this time though, I'm not multiplying, I'm dividing. What we're doing is a two-step where we're combining a multiplication with a division. So I'm dividing now by 6 over 6 because 600 divided by 6 is equal to 100, and that's what I wanted. And 420 divided by 6 isn't that bad to do, actually. It's going to be 70, and I have my answer. I need more chalk, so I can write it down. I have 70 over 100, which is 70%. So now we can see a reason to do 2 steps that makes things convenient for us. And we're just using our fraction skills. We're not even needing any decimal skills yet, so we're combining our fraction skills and our percent skills. How am I doing for time? Okay, so I want to do another one like that. This time I divided first. Sorry, how did I say that? This time I multiplied first and then I divided second. What if I were to do one where I'll divide first? Let's see if I can come up with an example where that would make sense. How about 180 over 240? 240 to turn that into 100, again, it's doable, but it's awkward. So instead, I'm thinking, well, what other denominator besides 100 is convenient, and then I could take that convenient denominator and get it to become 100. I know that 240 is a multiple of 20. So how do I get 240 to divide and turn into a 20? I'm going to divide it by 12 over 12. Again, I'm dividing by 1, so I can always do that. And 240 divided by 12 is indeed 20. And I see, yeah, that 20 is going to be easy to use in my next step. 180 divided by 12 is 15. Now I'm going to multiply as my second step because I want to get 100 as my denominator, and to get 20 to turn into 100, I multiply it by 5. So I'm multiplying this fraction by 5 over 5, a clever form of 1, and I get 100 as my denominator. That's what I wanted. 15 times 5 is 75, and it turns out that this is 75%. Some students would look at 180 over 240 and would realize really quickly that it is equal to 75%. But not everyone will, and then there's also the issue of you have to show how you're doing it. So realizing it early on is great, but you still have to find a way of showing it. I like this way of showing it. 2 steps, a combination of multiplication and division. Which one I do first depends on what fraction I started with. And I'm always at that goal of trying to get not just another fraction that's equivalent, to get a fraction that's really convenient, which is that fraction with 100 as the denominator. One more example. is it always going to result in these nice round numbers? Well, in the denominator, yes, we're trying to arrange our choices of what we divide and multiply by so that our denominators are numbers that are easy to work with. So I don't want to get a decimal in my denominator either in this step or in that step. But does it matter with the numerator? Let's find out by doing an example. So my next fraction is going to be 47 over 80. Okay, how do I get 80 to turn into 100? That's awkward. Yes, it can be done, but what if I turn 80 into 800 instead? I'm going to multiply by 10 over 10, and that gives me 800 as a denominator, and I know that's going to be convenient to use. 47 times 10 is 470. Now, of course, I have to divide top and bottom by 8 because I want to get the 800 to turn into 100. So I'm dividing by 8 over 8. And of course, the denominator is 100. But 470 divided by 8 is not going to give me a nice clean round whole number, and I don't care. 470 divided by 8, and I can use my calculator to find this if I want, although we all know that we could divide decimals, so we could do it that way too if we really needed to. 470 divided by 8 is 58.75. Yes, I have done that yucky thing, which is creating a fraction that has a decimal in it. But in this case, it doesn't bother me because that decimal, 58.75, is the numerator in a fraction that has a 100 as the denominator, which means I can just very quickly turn this into a percentage. It's going to be 58.75%. No problem. I don't mind having a decimal inside a number that is a percentage. It really isn't inconvenient. And it's not a problem for me because first I learned my fractions, then I learned my decimals, and then I started working with these percentages. So I'm just ready for these decimals. Okay, that's the end of my review because a lot of this stuff are things that we have done before in the past couple of weeks, and some of this stuff even in weeks far earlier than that. So I'm going to mention though, why would we end up doing this in a real life situation? I know as a teacher who has to give grades to students occasionally, this has happened to me an awful lot. That I have grades, but they don't have 100 as the denominator, but I want to record percentages as the final grade. If I end up with 58.75% for a student's final grade, well, all I have to do is a little bit of rounding. Now, I realize it's not a very good grade, but I made up this example at random, so it's not a real student. 58.75%, I can round that and say, well, that's equal to 59% if I have to enter it somewhere where we just want 2 digits. And that happens a lot when you're entering grades. So, real life situation where this is a useful thing to do. Now, I'm going to do some other type of examples, and we're going to get into the cross multiplication. We used cross multiplication quite a few times in the last lesson. We create proportions, which looks like a fraction with 2 fractions with an equal sign between them. And when we do cross multiplication, we actually are doing algebra. But this percent lesson is aimed at students who theoretically haven't started learning algebra yet. So what happens is we end up with a kind of an intro to algebra because it comes in so handy when we're doing the sort of problems that we're doing today. I'm going to erase. I'm going to remind you that always when you're learning math, always stop and remember to give yourself a stretch, maybe get out of your chair, do a sit-up or something if you need to so that you can feel comfortable because you need to be comfortable to learn. And do not hesitate to hydrate. Get a sip of your water when you need it. This is lime-flavored fizzy water, so I need a sip of it right now. And yes, that was more than a sip. And yes, it does have a hint of lime. How nice. Okay. Erase, erase, erase. Let's see, I have a whole bunch of examples here, but I have them written really small. We're just going to do a whole bunch of cross multiplications to practice them. So, when you do a cross multiplication, you start with a proportion. You start with what looks like a fraction, well, two fractions with an equal sign between them. And of course, if you're going to be solving for something, you have to have, one of the numbers has to be unknown, but you have to know the other three. So my first example, I have x over 36 equals 2 over 9. I'm not trying to turn either of these fractions into a percent. I'm practicing my cross multiplication skills. Now, how do I do that? And what happened here? What happens is you have three numbers that you know and one number that you don't know. So the goal is to find out the number you don't know. We want to find out what x is. So how do I do that? I do top times bottom equals bottom times top. X can be in this position, but it can be in any of the four positions, really. So long as I have three numbers and an x assorted somehow in here, I'm going to be able to solve it with cross multiplication. So we'll do some examples where x is in different positions just to prove that, yes, this always works. Top times bottom equals bottom times top. I'm going to start with this top times this bottom, so I'm writing 9 times x or 9x. And then equals bottom times top, I have to use the other bottom I haven't used yet, and the other top I haven't used yet, and that's the 36 times the 2. Now, do I have to put the 9 before the x? Not really. I can say x times 9, and it means the same thing. I don't have to put the 36 before the 2. I can say 2 times 36, and it means the same thing. So it's kind of flexible how you write it down. But it's flexible because we know that 3 times 4 is equal to the same thing as 4 times 3. With multiplication, it doesn't matter which one you put first. But by convention, we like, when we have a number with an x that are being multiplied, we like to write the number first and then the x after, and we call that number a numerical coefficient. That's all part of lessons that we don't really have to cover today, but it looks like this and we get used to it. Next thing I can do is simplify. I can do this multiplication, so I will. 9x equals 36 times 2, which is 72. Then I want my x alone. That's always the goal in algebra. I don't want to know what 9x is equal to. I do know what it's equal to. It's equal to 72, but that doesn't really help me because my goal here is to know what x is equal to. And since x is being multiplied by a 9, I don't want that 9 there. I'm going to do the opposite. I'm going to divide by 9. I'm dividing both sides by 9. So that I can cancel these. Now my x is alone. I wanted that. And 72 divided by 9 is 8. 8 times 9. Yes, it is. Okay, so knowing our multiplication tables is helpful. I have an answer. And cross multiplication is always going to look somewhat like this. You can have some flexibility about how you write it, but it always ends up solving the problem in this way. So let's do a bunch more examples to practice. I don't think I want to hold the clipboard the whole time. I'm going to leave it there, and I'm going to just copy down my next example, and we're going to do cross multiplication. The second example is 3/5 equals 15 over x. So you can see, this time I have the x over here in the bottom right, but it doesn't matter. I'm still able to solve and find out what x is no matter where the x started. So long as I have three numbers and an x, I can do this. Top times bottom equals bottom times top. 3 times x is equal to 5 times 15. And it gets to be very fast and easy because it always ends up going the same way. Simplify, 5 times 15, that's 75. I have 3x equals 75. Now I will divide both sides by 3. These cancel. X is isolated and it's equal to 75 divided by 3, which is 25. Is this the only way for me to show my steps? No. I want to show my steps in a different way with my next example. Let me peek at my next example. Yes. Okay, so there is room for flexibility in the style of how you show your steps. That's okay. There can be more than one way of showing how to do this. And the student who is comfortable with more than one way of doing it is in better shape than the student who has to have it always look the same way in order to understand it. How about 13/2 equals, and remembering to write nice and big this time, x over 8. So now the x is in the top right position. One way I can look at this, when I see the x on the top, I find this convenient. I can say, well, my x is on the top over here. and I'm just going to keep it there. So instead of trying to arrange to have the x on the left side, which happened in the previous examples, I'm going to say, no, the x is over there and I'm going to keep it there. I'm going to try to get everything else away from it without simplifying first. So instead of doing 13 divided by 2, which I could do, instead I'm going to say, well, I have a 13, I have this 2, that 8, my x is being divided by 8, so I'm going to multiply the other side by 8. I just rewrote this using algebra skills so that the 8 moved over here. It was x is being divided by 8 over there, so I'm multiplying by 8 over here. This still works. And now I can simplify. I have all the numbers together, so I can do it in more than one order. I'm going to do 8 times 13 and to divide by 2 later. 8 times 13, 80, 8 times 3, that's 104. But I still have to divide by 2. And I'm writing really big and getting really low on the chalkboard wall, so I'll end up doing this thing. Not planning ahead that well. 104 divided by 2, though, is 52. So I have 52 equals x. I have my answer. And I can verify. That's another thing. We can always verify these. So I don't always do it when I'm demonstrating it, but every now and then, why not? So how do I verify? I can say, well, let's rewrite this. 13 over 2, therefore, must be equal to 52 over 8. Yes, because I found that x is equal to 52. So I just wrote it again, but I replaced the x with a 52. And then there's more than one way of verifying it. I can divide both sides. These are divisions. Fractions are divisions. 13 divided by 2 is going to be 6.5. Now, I can do that without a calculator, but of course, if someone needs a calculator, they should use it. And I think I'll do 52 divided by 8 with the calculator. I think I could do it correctly without the calculator, but I think I'm going to use this method for verifying. So I'll even do the 13 divided by 2. 13 divided by 2, yes, 6.5. 52 divided by 8, 6.5. So I end up with 6.5 equals 6.5, which is the sort of thing that happens when you verify something, when the thing that you are working on is correct. So then that's not the only way that I can verify it. Interesting. Okay, let's do a bunch more example stuff. Next example. 1/4 equals 30 over x. 1/4 equals 30 over x. Top times bottom equals bottom times top. This time the top times bottom is giving me 1x. I'll write the 1 this way. Equals 4 times 30. But 1x means x. When the numerical coefficient of a variable is 1, you don't have to write the 1. You can if you want. So x is equal to 4 times 30, which is 120. So that one went rather quickly, but there was a 1 involved after all. Let's do some more examples. 5 over 6. 5 over 6 is equal to x over 72. Okay, so the numbers are getting larger, but that doesn't matter. We can still handle it. Where'd it go? Yes. Okay, so I am doing top times bottom equals bottom times top. I'm doing 6 times x equals 5 times 72. I might grab the calculator to do 5 times 72, but I might feel like I can do it without the calculator, and then I use the calculator to verify. 5 times 70 is 350, and 5 times 2 is 10. 350 plus 10 is 360. And I have 6x equals 360. I divide both sides by 6 so that I can cancel. X is equal to 60. So 5 over 6 is equal to 60 over 72. Okay, another one. And I'm going to point out something. Like I did with my earlier examples, when I was dealing with some percentages and expanding fractions, I'm going to point out that all of these examples so far have had lots of whole numbers. The answers have been whole numbers. I haven't been getting any decimals. But I shouldn't be afraid to get decimals. So soon, I'm going to have some examples where some decimals can happen. How about this one, though? That's not going to happen yet. 2/3 equals x over 54. 3 times x is equal to 2 times 54. 3x is equal to 108. I'll divide both sides by 3. X is equal to 108 divided by 3. Is it going to be 36? I think it's going to be 36. Yes, it is 36. Get your calculator if you need it. But I think I managed to do that. 2/3 is equal to 36/54. Who would have thought? Okay, another example. 6/7 is equal to 12 over x. And why are we doing all of these little cross multiplications when we're on a unit about percent? Because cross multiplication comes in so handy when we're solving problems that involve percent. That's why. Problems like maybe word problems that I might have a few of in our near future. Okay, 6/7 equals 12 over x. 6x equals 7 times 12. But 7 times 12 is 84, as we know if we know our multiplication tables. I'm dividing both sides by 6. Cancel, cancel. 84 divided by 6. Can I do that in my head? 14. X equals 14. Double check by looking at my notes, and yes, it is, but I also can double check by saying 84 divided by 6. Yep, 14. Okay, how about this one? 7/8 equals x over 12. Cross multiply 8x equals 7 times 12. Hey, that's 7 times 12. We had that in the last one, didn't we? Yes, we did. So we have 7 times 12 equals 84 again. But we're not going to divide the 84 by the same number this time. This time we're dividing both sides by 8. And what's happening when we cancel is 84 divided by 8 is giving me a decimal. It's giving me 10.5. And there's nothing wrong with that. So don't be afraid of decimals happening within these type of problems. The fact that decimals happen sometimes doesn't really change the steps at all. It doesn't make things any more difficult, and it just means that we can handle more problems with more stuff happening because of our decimal skills. Let's do a few more that are going to have decimals. 4 over 9 equals x over 20. Cross multiplying 9x equals 4 times 20, which is 80. We can see right away this is not going to conveniently give us a whole number. We're going to end up with a decimal, aren't we? We're dividing both sides by 9. X is isolated. 80 divided by 9. Now 81 divided by 9 would give a nice whole number. It would give 9, but 80 divided by 9 has to give a number that's a little less than 9, but it's going to be more than 8. So 80 divided by 9, oh, it gives us that decimal, and of course, yes, get the calculator and use it. It gives us a decimal that goes on and on. And it's 8.888888888. One of those that happens sometimes when you use a calculator or when you divide decimals. But we know how to handle that. It's 8.8. And then there are more 8s. I can write that as 8.8 repeating. That's one way of writing it. Or I can just round it. So I can say if I'm rounding it to the nearest tenth, I will call that 8.9. So there are different choices for how we deal with the decimals when we get them in our answers. So that's showing. That just barely is showing. I have to be more careful where I write these. And I wasted all this space up here. Let's do another one. 1 over 10 1 over 10 is equal to x over 45. I bet some of the students could do this one in their heads right away without having to write down anything. 1 over 10 equals x over 45. Yes, but I'm going to cross multiply. 10x equals 1 times 45, but 1 times 45 is equal to 45. So we're dividing both sides by 10. And of course, when we divide by 10, we can use a calculator if we need to, but we can also use techniques. Dividing by 10 is one of those ones where you jump the decimal. 45 divided by 10 is equal to 4.5. And I didn't have to do any rounding. It's just 4.5. So that happens too. When you have the decimal that keeps going and you have to do some rounding, well, you deal with it. And when you get a decimal that doesn't keep on going, well, then you could still decide to round this. We could round this to 5 if we really wanted to. To the nearest unit, 4.5 is 5. Another one. Let's do one that's going to give us crazy numbers. 7 over 11. Certain numbers, when you choose them, are more likely to give you decimals in your answers. 7 over 11. 7 over 11 equals x over, 100. We're doing that. We're trying to convert this fraction into a fraction over 100. We'll be able to give it in the form of a percent very easily, won't we? So now we're seeing, okay, so all this cross multiplication we're practicing, now it's sort of overlapping right back into what we started the lesson with, all of these percent calculations. This sort of thing will happen quite often when you're converting a fraction into a percentage, because not all numbers will very conveniently multiply and divide to give hundreds. You're going to end up with decimals. So cross multiplying, 11x is equal to 7 times 100. 7 times 100 is 700. So I have to divide both sides by 11. I have to do 700 divided by 11. Is it fitting? Yes. 700 divided by 11. I think I'll use the calculator for this, although I could peek at my notes. 700 divided by 11. And yeah, it's giving us one of those decimals that goes to the end of the display in the calculator. 63 point, and then I see this is another repeating decimal. I could use that line to show the repeating because it's 63.636363. It's kind of a beautiful number, actually. Who would have thought that 7/11ths, if I try to convert it into a percentage, would give me such a beautiful number? So it's 63.636363. That means I put the line over both the 6 and the 3 because 63 repeats. Or I round. I could say it's 63.6. But it's important that I have to put a percent. I guess I should show the percent here as well, even though I didn't leave enough room, because it's a percent. X is 63.63. But I can also say that 63.63 over 100 is equal to 63.6%. I think the way I'm doing this question, I'm just going to say that the answer, because all I was doing here, I wasn't doing a problem where I needed to give a percent as an answer. I was doing a problem where I had to say what x is equal to in the answer. X is equal to 63.63 repeating, or 63.6 if I round it to the nearest 10. That's fun. That's interesting. Let's do one more. 9 over 12. Now that's an easy one that I could avoid decimals with, right? 9 over 12. A lot of us are saying, oh, that reduces to 3/4. That's 0.75 in decimal. It's 75% in the form of a percentage. But I'm not finished asking my question. 9 over 12 is equal to 28 over x. Cross multiply, 9x equals 12 times 28. 12 times 28, I have my calculator. 12 times 28, 336. Now I'm going to divide both sides by 9. Cancel. X is equal to 336 divided by 9. I have another repeating decimal. I have 37.33333, so I'll write it as 37.3 repeating, and I'm done. Okay, that was the last example I put aside of this style. Now what I want to do with the rest of the time is I want to do some word problems. And the word problems really are percent. It's just that some of this math is going to happen in steps when we're solving the word problems. That's why I wanted to do a bunch of cross multiplication to practice it. Erase. Now word problems, the problem with word problems when I'm doing this is that I have to write the word problem and it takes time. take space on the chalkboard wall. But it's worth it. We do have to work with word problems. And the way I wrote these, they're not really great big giant paragraphs. They won't take that long to write. So my first word problem has to do with me buying tools for carpentry because, as you know, I am interested in doing that. So when I make up these situations, I like making up situations that really matter to me. So lately I have been shopping for a plunge router. Plunge router. Not the most expensive tool. It's not a very huge tool. But I'd still like to get a good price on it. So I looked at my local orange store, and then there's the red store. Now, I'm from Canada, so I think a lot of people know what the orange store is, but maybe a lot of people who are not from Canada don't know which red store I'm talking about. Doesn't matter, let's call it the orange store and the red store. Okay, so I need somewhere to write the problem so I have room to solve it. Let's see, I'll write it here. A plunge router costs, let me make sure this is fitting into the rectangle nicely. Okay, costs $129. At the orange store. I guess I should put the word "the" here, but I didn't. Okay, at orange store. At red store, it costs, now I would show you what a plunge router is, but I don't have one, which is why I'm shopping for one. At the red store, it costs $153. What percent more expensive is it at the red store? This would percent fit? Not really. There, now it fits. What percent more expensive is it at the red store? I'll just keep calling it at red store so I don't have to write the. Yep, red store. So this should look familiar. This type of question isn't very different from the ones we were doing last week. But we have to think our way through to how we're going to build our answer. And one of the things, and there's more than one choice actually, there's more than one choice for how you go through the steps. So as long as the student goes through all the steps that are necessary, they should get the right answer and it should be good. But the way I'm going to show it is the first thing I'm going to do is subtract. I'm going to say 153 minus 129. I'm not bothering to write the decimals with the zeros because they're both dollars amounts without pennies. 153 minus 129 is equal to, what is it, 24. So there's $24 difference. But that's not what the question asked. It said, what percent more expensive is it at the red store? So now I have to do a percent calculation. And the way I'm going to do that is I'm going to take the 24, which is the extra amount it costs at the red store, and divide it by the 129, which is how much it costs at the orange store, but I have to multiply by 100 in order to get my answer. Now I can write an X here, and I guess I will. Let's do our calculations. We have to do 24 divided by 129 times 100. We could do 24 times 100 divided by 129, but I like to do the division first. So I'm going to get my calculator because the calculator is definitely very helpful for these. We all know we can divide these with a pencil and paper. We've proven it, we did it for weeks, but we want to go fast through that division now because we're concentrating on our percent situation. 24 divided by 129 gives me an answer, but it's not a percent yet. It's a decimal. And then I multiply that by 100 times 100. And what I'm getting is 18 0.6, it's again a decimal that goes on, so I'm going to round it. X equals 18.6, but I have to put my percent symbol. It is 18.6% more expensive at the red store than at the orange store. Now, of course, we know what we do. What we do when we're shopping is we notice the two prices, and we tend to just notice which one is more. And we notice which one is less. So we might head right over to the orange store and buy it so that we end up getting it at a good price. But it's still useful to be able to calculate the percent difference, because sometimes you have more than one thing on your shopping list and you might have to decide, well, okay, so for this item, the orange store is definitely a better value, and I can see what percent difference it is, what percent more expensive it is at the red store, but maybe there are other things that are a better value at the red store. That's the way we really think when we are dealing with these prices. But this is how we show how to solve a word problem involving percent with this sort of situation. And we're getting right into the whole money thing, aren't we? Money is extremely useful when we're covering decimals and percent, so money tends to creep into the situations and the word problems quite often. Okay, looking at the amount of time I have left, I have 4 more problems I want to do, but just in case, I added another 3 problems in case I have time, because I'm really not so sure with word problems how long it's going to take. Okay, let's erase this one. After all that writing, here I am erasing it. But I know what store I'm going to be buying that plunge router at, and I'm telling you, this is truth. This is for true. That plunge router is in my future. My pretty near future, because I have some things I want to do with that tool. I already have a trim router, and there are things you can do with a plunge router that you can't do with your trim router. It's a good thing neither of these tools is very expensive. Okay, next word problem. Okay, I'm just going to say wax. I'm buying wax. I'm not going to write a type of wax because it's long. Butcher block conditioning wax. Here I am in wooden stuff again. I'm really in that mode, so I'm going to make my word problems fall within that mode. Today, wax costs $14.50. But on Tuesday, a sale price is advertised. That's next Tuesday. A sale price is advertised. What did I put the word advertised into this? Advertised. And I even put it in the wrong place. I meant to say a sale price of. I'm just going to write a not very grammatical sentence. On Tuesday, a sale price is advertised of, and even that, I'm not leaving enough room for the price, of $11.60. Okay, so what's the question? Fortunately, the question's not too long. What percent, need more chalk, will I save? Yes, I'm going to save. Yes, I'm going to wait until Tuesday. Of course I'm going to wait until Tuesday. I'm not going to rush and pay more for it right now. I still have a little bit of butcher block conditioning wax left in my bottle. So before I buy the next bottle, I'll wait for that sale. Okay, so what percent will I save? Let's build the question. And again, we have choices in how we do it, but right away what I want to do is I want to subtract. I want to see what the difference is just in price. So I'm going $14.50 minus $11.60, and the difference is $2.90. And I'll put a dollar sign. I really should put the dollar sign because it's not a final answer to the problem, but it is still an answer to a step in the problem, and it's money. So $2.90 is the difference. Then I want to take $2.90 and put it over the $14.50, because if I take the amount of money I'm saving, which is the $2.90, and put it over the original price, it's going to tell me what my percent is that I'm saving, and that's what the question's asking for. So there's different ways of asking the question where we're asking for different things that involve percent, so you have to read the question carefully. 290 over 1450 times 100, because I want it to be a percent. And I'll write equals x, but we have our x already isolated, so it's just all the calculations we have to do. We're going to divide and multiply. And notice how I wrote 2.90, 14.50. I really could have written 2.9 over 14.5. But it's money. So I like showing it, making it clear that it's money, and even within these steps that are not the final answer. 290 divided by 1450 times 100, and of course we can use the calculator for this, so I will. But I'll show the steps a little more. I'll do the division and show the answer, and then I'll multiply by 100 as a separate step, because really that is what we do. With the calculator, we can do it all at once. 2.9t divided by 14.50 equals, 0.2. But I have to multiply that by 100, so that's going to give me 20%, isn't it? We can sort of move the decimal, jump the decimal 2 places in our mind. Yeah, it's going to be 20%. But remember to write the percent symbol, because the answer isn't 20, the answer is 20%. Okay, so I can do that. So basically, whenever we're comparing prices, whether it's one store versus another store, or before the sale, after the sale, we can always calculate what the percentage is that we're saving. This is useful for calculating things like this. It's also useful for calculating discounts. If you get, for instance, an employee discount at the orange store or the red store, you tell me. If you get an employee discount at the orange store or the red store or any color store, you tell me. And you can calculate what your savings are if you know what percentage the discount is. It's a really useful type of math to know how to do. And of course, when we calculate tax, which I'm not doing today, that also involves calculating a percentage. So the math comes in handy again and again in slightly different ways. Let's do another word problem. My third word problem is not going to be about buying woodworking tools or woodworking supplies. It's going to be about tipping in a restaurant. And here I go erasing that paragraph that took me so long to write. Okay, fortunately these word problems are not very long. I think this one's even a little shorter. My bill, oops, let's erase everything. My bill is $32.50. Sure that fits in the rectangle, and it does. Okay. My bill is $32.50, and I wish to tip. And I wish to tip 15%. This thing about tipping, it's a cultural thing. You can talk to people about tipping, what percent tip is appropriate. And it's amazing the different points of view that you will get depending on who you're talking to and where they're from, and whether they're a person who works in a job where they depend on tips for their livelihood or not. But where they're from, that's an interesting one. I wish to tip 15%. Where is it? How much will my total be? Now, what do I mean by total? The total of my bill plus the tip. So I want to know what the total will be, and I think I need a question mark here. So, I don't want to say anything bad about people from a different country from me, so I'm going to be careful how I say this. But I've been to a country on a vacation at a resort where about half of the people were from Canada, where I'm from, and half were from Italy. And this is just because of where the charter flights fly, because those resorts tend to fill themselves with people from charter flights that might come from this country or that country. But my wife Bunny and I talked to some of the staff members. We made friends with some of the staff members in the hotel. And the staff members told us that the Canadian tourists are very much more popular than the Italian tourists. with the staff members. And we said, why? And they said, well, because the Canadians tip better. So that's that thing, that cultural thing. But to understand it, you have to understand that some countries automatically put a tip, often 15%, on every restaurant bill, and you have to pay it no matter what, no matter whether the service was good in your opinion or not. And so people who are from countries like that, and Italy is one of those countries, they don't tip. They might round up their bill a little bit, but they don't tip because they feel they already tipped. And what happened in that resort was that some of the people didn't realize that no tip was being added to their bill. So they're in the habit of never tipping, so they don't tip very much. And then in Canada, it's not normal to add an automatic tip to a bill. I've seen it happen. It happens in the odd place, but it's not normal. So Canadians are used to tipping, and we calculate our 15%. We do this sort of thing a lot, actually. This is a sort of math that real people do, often in their heads, in real life situations very frequently. So my bill is $32.50, and I wish to tip 15%. I want to know what 15% of $32.50 is. This sounds so much like the questions we were doing last week. It's just rephrased into that from a word problem situation. My bill is $32.50, and I wish to tip. So what I'm going to do is I'm going to say this is how I'm going to build it. X, which is what my total is going to be. Wait a second. No, that's not going to give the total, so I'm going to do two steps. X is equal to 15 over 100, that's the 15%, times the 32.50. So I'm using that dot for multiplication. Maybe it's more clear to put a multiplication symbol in X, but we're used to doing the X and the dot, and the students know what we're doing. Okay, 15 divided by 100 times 32.50 is going to give something, but it's not going to give the total. It's going to give 15% of 32.50. And there's that of thing again. The word of often, when translated into math, means multiply, and this is one of those cases. So I'm going to get out my calculator. 15 divided by 100, which I know is going to give me 0.15. Yes, times 32.5 is 4.875. But 15%, this is money. So I want to round it. It would round to $4.88, and I'll even write the dollar sign. But that's the tip. The way I built this, I just calculated the tip. I didn't calculate the total, so I'm going to have to add the 32.50 plus the 488. And here I am adding decimals. Good thing we know how. So we have 8 plus 5 is 3, carry the 1, 4 plus 6, 7. I have to put my decimal here. I forget to do that, and I should have done it earlier. That happens a lot. And then this 3. So $37.38 is going to be my total. Now, if I'm doing this, and I realize that I want to tip $4.88, it might be very normal that I just say, okay, that's pretty close to $5, and I just pull up a $5 bill, and then I ended up tipping a little more, which means my total was a little more. But that's beside the point. If you want to know what your total will be, if you add this size tip to that size bill, this math will solve that problem for you. And remember what I said, in many countries, including a lot of European countries I've heard of, if the bill was $32.50, they wouldn't bring you a bill that says $32.50. They would have added the 15% already, and they would bring you a bill that says $37.38. And then you might say, well, I'm going to round that up to $37.50 or $38, just because it's more convenient. I don't want to be counting coins. And whether that happens or not before you receive the bill or whether you do it after the bill depends on where you're from. Kind of interesting. Okay, I'm going to do another one. Where am I at? How am I at for time? I'm doing okay for time. I don't know if I'm going to use those extra problems that I made just in case. I've done 3 of my problems. I'm going to do 2 more. And these next 2 are also about tipping situations. and I had said it's not only where you're from and whether they put the tip on the bill automatically that will have an impact on your opinion about tipping. It's also whether you have ever tried to live off of tips. I have a sister who used to work in a place where she had to live off of tips, but it wasn't a place where she got very good tips, and she was always struggling a little bit and didn't necessarily get the tips she was hoping to leave work with. And when that sister would go through, say, a Starbucks drive-through, she's a big tipper. She's a big tipper at Starbucks and everywhere else because she knows how it feels to need those tips. So she feels for those people and she tips well. There's all sorts of things that come into our opinion about what percent we should tip. And that's kind of interesting. It's an interesting thing in itself. It's mathematical and cultural at the same time. My bill is $84. My bill is $84. Decimal and period. Okay. And I tipped $12. Okay, so this time I know how much I'm tipping. And this is often the way it will go. That a person will look at their bill and decide how much to tip. But if I'm wondering, well, what percent tip is that? Well, that's the next question, isn't it? Yes, what percent tip did I give? What percent tip did I give? Now, if you do your tips that way, where you look at the money and you sort of just think, oh, I think I'll give this much, and then you calculate it later, sometimes what will happen is you realize that you tipped more than you expected to, oops, or that you tipped less than you expected to, which is also oops. So maybe doing the math before you actually pull out the money is a good idea. Okay, I'm the sort of person who, when I'm eating in a restaurant, the other people I'm eating with say, Doug, what's 15% of this? I guess I'm known to be mathy. So I do these calculations a lot, not only for myself. Okay, so how am I going to solve this? I'm going to say, well, what percent tip did I give means I want X to be the numerator in my, well, what percent means what number out of 100. So I can just build this fraction with the X in it right away. And I'm going to multiply that by the $84. But that has to give me 12. So this time my X isn't isolated on one side of the equal sign, but I'm still able to turn this into an equation that's going to solve it. And knowing about the percent meaning a number that's over the numerator in a fraction with 100 as the denominator is just so useful when we're doing this. So X times 84 over 100. Now I can isolate my X all at once. And I was doing an example like that earlier. I can say, well, X is going to be equal to 12. Keep the X, keep the equals 12. But I'm going to multiply the 12 by 100. And I'm going to divide that by 84. So I can get everything all to one side of the equal sign if I want all the numbers so that I can simplify. I'm going to end up getting X equals 1200 divided by 84. And that's when I'm going to grab my calculator. 1200 divided by 84 is 14.2857. So we're going to round, and I'm going to call it 14.3%. So if I wanted to tip 15%, and I saw that bill and I decided to tip this amount, then I do my calculation. Well, actually, that's quite close to 15%. It's a little lower. So I might, if I realize that, I might say, you know what, I'm going to give $13 instead of 12 if I feel like tipping a little more than 15%. But getting it that close is actually pretty good. There's some good estimation going on here. If you believe 15% is an appropriate tip, which usually I do. Okay, one more. I have time for one more. Very little time, so I'm going to do it fast. I'm not going to write down the problem. I'm going to say the problem. Wait. I tipped $7. So I'm changing this one. I tipped $7. Oh, but it was a 20% tip. No, I can't really just fill in this. So what I'll do is I'll write it in point form. Tipped $7, 20% tip. Okay, that percent symbol is really messy. What was the bill before the tip? Bill, there. Nice and fast. And how am I going to set up my math? I'm going to say $7, and I'll write 7.00 because it is money, equals 20 over 100 times X. And it makes sense. $7 is 20% of what? Of meaning multiply. That happened again. So then if I want to isolate my X, the $7 is going to be multiplied by 100 and then divided by 20. 7 times 100, that's 700 divided by 20, and the answer is going to be, I didn't even grab the calculator, I had the answer already written down. The answer is $35. So this means that if I tipped $7 and it was a 20% tip, oh, a generous 20% tip, then the bill must have been $35. So all the three numbers that are involved in these percent calculations, you can always do word problems where two of the numbers are known and the other number you have to figure out. And it doesn't matter which of the three is the unknown. We have math that will work, and the math isn't really all that different. You just have to arrange your equations so that it'll work. And with that, I have now reached the end of my time. So, oh, and this dog has been sitting there behaving herself so well all this time. So we are both going to say goodbye because somebody, some furry buddy, wants her supper, and so do I. So as usual, it has been a pleasure teaching you about percent, and I will see you next time.